1 on both sides. We can do the same thing, divide by m, and it cancels out. Plug everything in. 1/2 v squared equals 9.8, and we're trying to solve for h. I'm sorry, this v right here should be 10. 10 squared. 1/2 times 10 squared equals 9.8 times the height. Gotta watch myself. Ten squared is 100. Hope everybody knows that. And 100 times 1/2 or divided by 2 is 50. 50 equals 9.8 times h. And if we divide by 9.8 on both sides, you should come out with a height of 5.1 meters. And the big question is, will he make it safely? Well, he only has enough energy to go 5.1 meters, which will only get him about right here. So no, he doesn't make it to the top, and unfortunately it looks like the gorilla will get the best of Tarzan today. Let's look at the next problem. We have a cat, a 400-gram cat. It's thrown upwards at 15 meters per second. And you want to know the potential energy, kinetic energy, and total energy at all these different points. So let's go down the list. The very first thing I want you to notice is this, that 400 grams is not in the right units. We've got to have our mass in kilograms. And to go from grams to kilograms, we go 3 decimal places to the right or divide by 1,000. So this is going to be 0.4 kilograms. That's the mass of our cat, 0.4 kilograms. So we want to know potential energy, kinetic energy, and total energy immediately after the cat is thrown. So here we go. Cat's going to be thrown up in the air. Here's the initial energy state. Here's the final energy state. Immediately after it's thrown, we'll be down here at the initial. Immediately after it leaves the hands, we're going to just assume that this cat is thrown from what's going to be ground level. We're going to call it ground level. So we're going to assume all the energy down here is kinetic. It's all kinetic. Okay? So if it's right after it's been thrown, the potential energy has to equal 0. It doesn't have any height yet. And that would be this answer right here. 0 joules. That's the potential energy. What's the kinetic energy after it's thrown up? Well, kinetic energy, actually we'll use E sub k, is 1/2 mv squared. Substitute everything in, you get 1/2 times 0.4 is the mass, times 15 is our velocity. We see that right here. I'm going to plug that in right there. And make sure that gets squared. 15 squared times 0.4 divided by 2, and you will come out of a kinetic energy to start out with of 45 joules. So this will be the initial energy. Since all the energy down here is kinetic energy, it's going to be 45 joules of energy. That's our total energy, in fact, at this point, because total energy has to be the potential energy plus the kinetic energy. Potential energy was 0, kinetic energy was 45, and 0 plus 45 equals 45. That's the conservation of energy for you. So from this point on, potential and kinetic energy have to add up to 45 joules. All right, so let's go on. Potential, kinetic, and total energy at a height of 3 meters. All right, so now we're somewhere in the middle here on our picture at a height of 3 meters. All right. Well, I can tell you what total energy is right now, because I know from conservation of energy, total energy does not change. So the total energy must be 45 joules. It has to be. And that's our answer right here. 45 joules. Potential energy has to be the same, or total energy has to be the same, rather. All right. Now we have to find either potential energy or kinetic energy. Well, to find kinetic energy, we need to know the velocity. And I don't know the velocity yet. It hasn't told me anything. I could probably use a kinematic equation to solve for it, but I don't really want to do that. But what I can do is to find potential energy, because potential energy just depends on the height, which they gave us. So U sub G, gravitational potential energy, I'll just put that right here. It's the same thing as potential energy, equals mgh. Plug everything in and you should get 0.4 times 9.8 times 3. Work all that out. 0.4 times 9.8 times 3, and you should get 33.2 joules, which is this answer right here. That's the potential energy. And since the total energy is 45 joules, energy total, E sub T, is going to equal potential energy plus kinetic energy. So that's going to be 33.2 plus kinetic energy. So basically, and that's going to equal 45, because we know the total is 45. So 45 minus 33.2, that brings you to a kinetic energy of about 11.8 joules, which is this answer here. 11.8 joules of kinetic energy at that height. And if you wanted to, since you now have the kinetic energy, you could calculate the cat's velocity or speed at that height. But we don't have to do that. Let's move on to the next one. At the top of its flight, so we're going to this part right here, at the final energy state, at the top of its flight, what's potential, kinetic, and total energy? Same thing though, total energy, E sub T, has to be 45 joules. Still, that's never going to change. And if we reason at the top, when it reaches the very top, that cat is not going to be moving anymore. So the kinetic energy is going to be straight up 0. It has no more kinetic energy. All the energy has now been transferred from kinetic energy into potential energy. The potential energy is the entire energy, and since the total energy is 45, the potential energy must be 45 joules. There's that answer, and there's that answer. That's how we get that. So C, you don't even have to do any calculations. But if you wanted to, you could. I don't even have to know how high this thing will go. But I can now calculate, because I know that the potential energy at the top of its flight is 45 joules. I can bring that down here, and it asks what's its maximum height. Well, I know that potential energy equals mgh. I have the potential energy here, so I can plug that in for potential. 45 equals 0.4 times 9.8, and I'm going to solve for the height, right? So 0.4 times 9.8, and if you calculate that out, do that real quick, 0.4 times 9.8 will give you 3.92. H equals 45. Divide both sides by 3.92. And you should come out with a height, make sure this is right, divided by the answer, should come out with a height of 11.5 meters, which is what we get here.